Hey everyone, so we're looking at section 5.3 today. As you can see, this is where we are going to talk about the nonlinear system of equations. So in 5.1, we reviewed how to solve a system of equations that have two equations and two variables. In last section 5.2, we talked about how to solve three equations with three variables, which was of course your three-dimensional coordinate system, and now we're talking about non-linear system. So when we're talking about non-linear equations, basically what you need to know is that the graph of a non-linear equation is not going to be a straight line, right? Because non-linear basically means it's not a straight line. So if your system has at least even one equation which is a non-linear equation, then of course we can say that the whole system is a non-linear system. So examples of your non-linear equations could be a quadratic function over here, so 3x squared, which of course would be a parabola. You have y equals square root of x, y equals absolute value of x, y equals 10 to the power of x, which is of course your exponential function, and y equals log of x, which of course is the logarithmic function. So you can have a quadratic function, a square root function, absolute value function, exponential function, or logarithmic function. These are just examples. There are obviously more nonlinear equations that are out there. So let's see how we can solve these systems. So we're talking about solving by elimination of variables. So kind of what we had done with the addition method before, that's the same thing we're talking about here. So they are saying, however, since the graphs of nonlinear equations are not straight lines, graphs might intersect at more than one point. So that is something we have to keep in mind. Unlike linear equations, with nonlinear equations, since your graphs can intersect at more than one point, that means your solution set will obviously contain more than one point. So we are actually going to start by the graphing method first. So to solve the system of equations, we are going to sketch each equation and then see where the two equations would intersect. So we're starting out with our first example here, y equals x squared and y equals x. So let's take a look at this. So for y equals x squared, let's go ahead and do a table. And here again, we can use -2, 0, 1, and 2 for our x values. And of course, we'll do another table for the y equals x function. And I'll use the same 5 points over here as well. So for y equals x squared, that means you are doing -2 squared, which will give you +4. -1 squared will be +1. 0 squared, of course, will be 0. 1 squared is 1, and 2 squared will be 4. For the y equals x function, so whatever is the x value, of course, is going to be our y value. So this would be -2, -1, 0, 1, and 2. So let's go ahead and graph both of these functions, and let's see what we end up with. So at -2, we are at +4. -1 is +1, 0, 0, +1, +1, and then +2, +4. So this is kind of what this function would end up looking like. And this is, of course, our y equals x squared function. And then when we graph y equals x, that's at -2, -2, -1, -1, 0, 0, 1, 1, and then 2, 2. So this graph will end up looking like something like this. Y equals x. So if you will notice, in both of these functions, we had 0, 0, and 1, 1 as our common points. You can see that in the table, and you should also see that on our graph over here. So we've got common points where the two graphs are intersecting is at 0, 0 and is at 1, 1. Okay, so let's look at our graph here on our Desmos calculator, and if we zoom in just a little bit, you will notice how our two graphs are intersecting at those same points that I talked about. So you can see 0, 0 at the origin, and then 1, 1 right here on both our y equals x squared and y equals x function. Okay, so in this case, we will say the solution set for this system is going to be at the ordered pairs 0, 0 and 1, 1. Okay, so this is kind of what we were talking about, that you would see more than one point where the graphs could intersect, and so you can have more than one solution for your graphs over here, or your systems over here. Alrighty, now let's go ahead and look at this second example. We are given y minus x equals 3 and y equals absolute value of 3. So let's see what these graphs end up looking like. Okay, so you can actually go ahead and rewrite that first equation by moving the x to the other side. And we basically end up getting y equals x plus 3. Now you can use the slope and the y-intercept to graph this. Of course, our slope, this one has a coefficient of 1, so slope is going to be 1 over 1. And the y-intercept is going to be the point 0, 3. So this graph will be at 0, 3, and then positive 1 over 1. So that will be, you can go up 1, right 1, or you can go down 1 and left 1. Okay, so this will give us a good idea for our graph. So this guy is y minus x equals 3. Now for our second graph, y equals absolute value of x, let's do a table for this. So again, we can use -2, -1, 0, 1, and 2. Now, of course, absolute value, we know, is the distance from 0. So that means all our values become positive. So -2 will become +2, -1 will become +1, 0 will stay 0, 1 will stay 1, and 2 will stay 2. So when you graph this, we will have, let's see, -2, +2, -1, +1, 0, 0, +1, +1, and +2, +2. So let's see, this arm will go this way, and then this arm will go this way. And this is going to be our y equals absolute value of x. So you will notice that these two graphs are intersecting right here. Now, I don't know if you are able to recognize that point or not, but that's going to be halfway between -1 and -2 here on the x-axis, and halfway between +1 and +2 on the y-axis. So it will actually be, if we write it as a fraction, -3/2 and +3/2, or if you want to write this as a decimal, -1.5 and +1.5, though you cannot leave your answers as decimal values. You have to write them as fractions. So this is just for you to know that where the points are, but we definitely need them as fractions. Okay, so again, just to show you on Desmos calculator over here, so you will notice where the two graphs are intersecting, you are right halfway between -1 and -2 on the x-axis, and then you are halfway between +1 and +2 on the y-axis. So this is right there at -1.5 and +1.5. But again, like I said, make sure you're writing your solutions as fractions and not decimals. And again, you can see the graphs only intersect at one point. So our solution set for this system is going to be negative 3/2 and positive 3/2. And there you go. Okay. All right, we've got one more graphing example over here, and we are given y equals absolute value of x and y equals x squared. So let's go ahead and graph these two functions. So both of these, we can do a table. Okay, so these, we just did this table, so these guys will all become positive, and then let's do another table for y equals x squared, which is what we did in the first example. So these will be 4, 1, 0, 1, and 4. So let's go ahead and graph these guys. We've got negative 2, negative 2. I'm doing the absolute value of x first. Negative 1, negative 1, 0, 0, positive 1, positive 1, and then positive 2, positive 2. Okay, so something like this. This will be absolute value of x over here. And then let's do our y equals x squared function. So that's negative 2, positive 4, negative 1, 0, 0, 1, 1, and then positive 2, positive 4. So this guy will look something like this. Oops. Okay, so this will be our y equals x squared function. So again, if you can see, they are intersecting at 0, 0, at 1, 1, and at negative 1, positive 1. Okay, so it looks like they are intersecting at 3 different points between these two graphs. Okay. Okay, so again, back to our Desmos calculator, you can see that these guys are intersecting right here at 0, 0. They're intersecting here at positive 1, positive 1, and intersecting here at negative 1 and positive 1. So 3 different points where the two graphs are intersecting. So when we write our solution set for this system, that is going to be negative 1, positive 1, 0, 0, and then positive 1, positive 1. So those will be our 3 solutions for the system of equations over here. Okay? Alrighty, folks. Now, let's talk about how we can do the elimination method to help us solve these examples over here. So we are given, again, 2 nonlinear equations over here. X squared plus y squared equals 5, and x squared plus 4y squared equals 14. You should recognize that first equation, because that first equation is the equation of a circle, and the second equation, we haven't talked about it, but we will talk about it in chapter 7, is actually the equation of an ellipse. So basically, think about this. You have a circle that is being intercepted with an ellipse. So if that's the case, you are going to have 4 points of intersection between those two shapes. So let's go ahead and take a look at how we can solve an example like this. Okay, so we're going to use the same process that we did with our addition method and try to get rid of either the x squared variable or the y squared variable. So you will see I have both my equations which have x squared and x squared on them, right? Let's call this guy equation 1, and this one will be equation 2. Okay, and let's go ahead and get rid of our x squared, because that will be an easier one to eliminate. So to eliminate x squared, we are going to add, let's see, how about we do negative 1 times equation 1, so multiply that by negative 1, so that will have a negative x squared, and then add that to equation 2. So we're going to take our first equation and multiply it by -1. So that will end up giving us -x squared -y squared equals -5. We'll keep our second equation as it is. So that's x squared plus 4y squared equals 14. And then we'll go ahead and add both these equations. Of course, your -x squared, +x squared will cancel each other out. Positive 4y squared minus y squared will end up giving us 3y squared. And then 14 minus 5 will of course end up giving us 9. Now of course we want to find the y value, right? So that means the first thing we want to do is isolate the y square. So let's go ahead and divide both sides by 3. And we will end up getting y squared equals 3. Now to get rid of the square on the y, we'll need to use square root. And remember, with square root, we get one positive and one negative root. So the square and square root will cancel out, leaving us behind with y equals positive and -3. So you are actually getting two values for y over here. One of them is positive square root of 3. The other one is negative square root of 3. So what that means is we have to use each value of y to find out what our x values are going to be. So let's start with the first one, y equals positive square root of 3, and let's see what kind of x values we can get. So we are basically finding x at this point. And I think I'm just going to use my first original equation to help us find the x value. So that's x squared plus y squared equals 5. Okay, so this will give us x squared plus y is square root of 3 squared equals 5. And of course your square root and square will cancel each other out, leaving us behind with x squared plus 3 equals 5. Subtract 3 on both sides. And again, of course, we're trying to get x by itself. So we get x squared equals 5 minus 3 is 2. Again, we'll take square root on both sides, which will give us a positive and a negative root. And we end up getting x equals positive or negative square root of 3. And remember, this was only when we used y as positive square root of 3. So that's actually giving us two answers. So you have positive square root of 2 for positive square root of 3, and you have negative square root of 2 for positive square root of 3. So we're getting two sets of answers from here. Now we're going to repeat our process, but this time, since we used the positive one already, now we're going to use the negative one. So to find x, now let's use y equals negative square root of 3. And I'm going to use the same equation again. You can use equation 2 if you like, but this one just seemed easier to work with. And then again, replace your y with negative square root of 3, and that's going to be squared. Now, of course, you are doing negative square root of 3 times negative square root of 3. So the two negatives will become positive, and then square root of 3 times square root of 3 will just become 3. So in this case, your square cancels out the square root, but also makes this negative sign a positive. And you end up getting x squared plus 3 equals 5. Again, get x by itself. Move the 3 to the other side. And you end up getting x squared equals 2. To get rid of the square, again, we'll do a square root on both sides. We get a positive and negative root. And this one also will end up giving us x equals positive or negative square root of 2. Which means, now remember, this time our y value was negative square root of 3. So the ordered pairs you get from here will be positive square root of 2, negative square root of 3, and negative square root of 2, and negative square root of 3. So basically, all four of these are going to be, like I said, we were going to have 4 points where these two graphs would intersect. So these are going to be part of our solution set over here. And basically what you have is positive and negatives of square root of 2 and square root of 3. So you will have negative, hold on, square root, oh boy, square root of 2, negative square root of 3, then negative square root of 2, positive square root of 3, positive square root of 2, negative square root of 3, and positive square root of 2 and positive square root of 3. So making sure that we are including all 4 of these in our solution set. So this is our positive square root of 2, positive square root of 3 from the first one here, negative square root of 2, positive square root of 3, and then my third one was positive 2, negative square root of 3, and the last one was negative square root of 2, negative square root of 3. So all 4 together will become our solution set. And this is going to happen anytime you have a system of equations where you have both equations with x squared, y squared, and x squared, y squared. Okay, so that's why we came up with 4 different ordered pairs for this guy. Okay, alrighty, so this is how your addition method would work for these nonlinear system of equations. Now let's go ahead and take a look at example 5 over here. So you will see these ones are given to us as 3 over x minus 1 over y equals 13 over 10, and 1 over x plus 2 over y equals 9 over 10. Now in this one, I would not recommend getting rid of our denominators because that would make this problem a lot longer and more complicated. So leave them the way they are and try to use your addition method to eliminate either the x variable or the expression that has the x variable, or try to eliminate the expression that has the y variable. So let's go ahead and take a look at this one. Okay, so you will notice here that our y variables already have a positive and a negative sign, right? So the only thing we would have to do here is to be able to cancel these guys out. If you could have positive 2 over y, and if you could have negative 2 over y, then they would basically cancel each other out. So since I already have positive 2 over y in my second equation, you want to make the first equation as the negative 2 over y. So that's actually going to be our strategy over here. So let's call this guy equation 1. This one will be equation 2. So we are going to eliminate our y variable. And to do that, we will need to multiply our first equation by 2, or if it helps, you can think of it as being 2 over 1. But basically, you're multiplying by 2. So in this case, we will add 2 times equation 1 and add that to equation 2. Okay? So when we do this, our first equation will become, that's going to be 2 times 3, which will give us 6 over x, minus 2 times 1 will be 2, so that becomes 2 over y, equals 13 times 2 will of course become 26 over 10. All right, we'll keep our second equation as it is, no changes. So 1 over x plus 2 over y equals 9 over 10. And then of course we're adding both equations. Okay, so here you will see once we multiply the first equation by a positive 2, now I have negative 2 over y and positive 2 over y, which will end up canceling each other out. For my x terms, I have 6 over x added with 1 over x. So just think about it. That's 6 over x being added to 1 over x. I already have a common denominator of x, which means I'm just adding the numerators, which will give me 6 plus 1. And that will be 7 over x on this side And then on the right hand side, you have 26 over 10. And we're adding this with 9 over 10. Again, common denominator of 10, which means you're just adding 26 plus 9, which will of course come out to be 35. So this will become 35 over 10. And then of course we want to try and get x by itself. Okay, so since you have 7 over x equals 35 over 10, these are basically set up as proportions, so we can do cross multiply. Now if you wanted to simplify 35 over 10, you can. If you don't simplify, you will actually still get the answer either way. So we are multiplying 35 times x, which will give us 35x. 7 times 10 will of course end up giving us 70. And then to get x by itself, divide both sides by 35. And you will of course end up getting x equals, and 35 will go into 72 times. So there you go. We are able to come up with our x value. And then now what we want to do is of course go back and find the y value. So you can use equation 1 or equation 2 to find y. And I think I'm going to use equation 2 for this. Okay, so let's find our y value. So we have equation 2 as 1 over x plus 2 over y equals 9 over 10. And our x value is going to be 2, so that'll be 1/2 plus 2 over y equals 9/10. So let's subtract that 1/2 from both sides. You will be left behind with 2 over y. And then what is 9/10 minus 1/2 to simplify that right hand side? So of course we need to find a common denominator. So 10 can be our common denominator. So multiply this side by 5. You will end up getting 9/10 will stay the same. And the second fraction will now become 5 over 10. Now that you have your common denominator, 9 minus 5 will give you 4. So you end up getting 4 over 10. Again, you can reduce that or just solve for y and it will end up canceling out on its own. So same thing, cross product over here as well. And we will end up getting 4 times y, which is 4y. 2 times 10 will be 20. Get y by itself, divide both sides by 4. And you end up getting y equals 5. Okay. There you go. And it's never a bad idea to check your final answers. So if we check in the original equations, 3 over x minus 1 over y equals 13 over 10. This will be 3 over 2. Yeah, 3 over 2 minus 1 over 5 equals 13 over 10. To find our common denominators, we would multiply this fraction by 2, multiply this fraction by 5, and 5 times 3 is 15. Oops. And of course, 2 times 1 is 2 over 10. When you subtract 15 minus 2, you end up getting 13 over 10. And of course, you will see we get a true statement here, so it checks out on the first one. Now a quick check for the second one, which is 1 over x plus 2 over y equals 9/10. So again, this will be 1 over 2, 2 over 5. Same thing, find a common denominator, multiply this side by 5, this side by 2, and we will get 5 over 10 plus 4 over 10, and 5 plus 4 will give you 9. So 9 over 10 equals 9 over 10, and again, we have ourselves a true statement. So since we had our variables in the denominator, this was a good one to check and make sure, we didn't make any errors, we didn't miss anything, because it would, be terrible to go all the way till the end, plug your answers in, and then realize we did something wrong. So of course in this case our ordered pair is coming out to be 2, 5. And so when you write your solution set, these two graphs are intersecting at only one point, and that's going to be at 2, 5. Okay. Alrighty, so there you go. This is how we go about solving number 5. Now let's take a look at number 6 over here, which is asking us to find the exact solution to the system y equals log of x plus 1 and y equals 1 plus log of x minus 1. Okay, so let's take a look at this one over here. So let's say this guy here is equation 1, this guy here is equation 2. Now in this example, instead of using the addition method, we are actually going to use the substitution method. So what we are going to do is we are going to substitute equation 1 into equation 2. So that basically means you are going to take this value here and replace it for y in your equation 2. So you're basically setting the two equations equal to each other. So this will end up giving us log of x plus 1, and this is replacing the y on the left hand side, and then the right hand side will of course stay the same, which is 1 plus log of x minus 1. So what I'm going to do is I am actually going to get my logarithms on the same side. So let's go ahead and subtract this guy here, log of x minus 1, and take it to the left hand side. So this will cancel out here, and we will end up getting log of x plus 1 minus log of x minus 1 equals 1, right? Now you should recognize that since we are subtracting two logarithms which are both base 10, or basically common log, since they are being subtracted, I can actually use the quotient rule for logarithms over here. And quotient rule basically means you keep that common log, and then the first parentheses becomes our numerator, so x plus 1 goes on the top. Second parentheses becomes the denominator, so x minus 1 will go on the bottom. Okay, so by using our quotient rule, we are reducing this down into a single logarithm. Now, because we still want to solve for x, right, because we're still trying to figure out what the value of x is going to be, we are going to convert this into an exponential format. So again, remember the way we make this transformation. You have base a raised to the value of y equals x. So of course we know these are common logs, which means they have base 10. So your base 10 is going to be raised to this power of 1, which is on my right hand side, and that's going to equal our parentheses of x plus 1 over x minus 1. So this is how we would go about converting it from a logarithmic form to an exponential form. And now let's go ahead and solve this. Okay, so now of course our goal is to find a way to get our x terms together. So 10 to the first power of course just means it's going to be the number 10. So I'm actually going to start by multiplying both sides by x minus 1 to get rid of that denominator on the right hand side. And then of course we will need to distribute this 10 inside the parentheses. So 10 times x will give us 10x, minus 10 times 1 will give us 10, and then we are left with x plus 1 on the right hand side. Now let's get our x terms on the same side. So I'm going to go ahead and subtract this x from here, and I want to bring my constant terms on the right hand side, so I'm going to add 10 and move it to the right. So my x on the right hand side cancels out, and my 10 on the left hand side cancels out, leaving us behind with 10x minus x will be 9x, 10 plus 1 will be 11. Get x by itself, divide both sides by 9, and we end up getting x equals 11 over 9. Okay, so that's kind of how this example would work out. Now, once you have found your value for x, then of course we want to go back and find our y value now. So to find y, you can use either equation 1 or equation 2, but I think equation 1 is going to be a little bit more straightforward, so let's use that. Y equals log of x plus 1. So that would be log of x, which is 11 over 9, plus 1. Go ahead and add those together. So that will end up becoming 11 over 9 plus 1. You can write it as 1 over 1. Find your common denominator. So 11 over 9 plus 9 over 9. 11 plus 9 will become 20. And so that becomes 20 over 9. And we're actually going to leave our answer right here because 20 over 9 is going to give us some kind of a decimal answer. So we will actually leave it. And that's especially because they had also asked us to find the exact solution, right? They did not want a decimal approximation. So since they want an exact solution, your ordered pair is going to be for the x value 11 over 9, for the y value log of 20 over 9. Okay, so when we write our solution set, that's going to be 11 over 9 and log of 20 over 9. And that's going to be your ordered pair. Okay, so this is how you would have to go about solving some examples that look like number 6, where you're going to have logarithmic functions in there. Okay. Alrighty, folks. So that brings us to some application examples over here. And they're telling us that we have to find two complex numbers, okay? And they're telling us when you add those two complex numbers, the sum is going to be 6 and their product is going to be 10. So let's say our two complex numbers are x and y, okay? And you can use any variables you want. I'm just going with x and y. So they're telling us when we add these numbers, the sum is 6, so that will give you one equation. And they're telling you when you multiply these numbers, their product is 10. So that's how you come up with your two equations over here. So x plus y equals 6 and x times y equals 10. So let's see how we can solve number 7 over here. So I've already got my equations. Let's call this equation 1. And let's call this equation 2. So obviously you can see the addition method is not going to work in this example either. So we are going to go ahead and use substitution. So we're going to take our first equation and rewrite it either for x or y by itself. So how about we go ahead and get y by itself and move that x to the other side. And this will end up becoming y equals negative x plus 6. And let's call this guy, since we rewrote it, as equation 3. Okay? So we are going to do substitution, where we are going to substitute equation 3 into equation 2. You don't want to substitute equation 3 into equation 1 because remember, equation 3 is just equation 1 that has been rewritten. So what we're actually going to do is we're going to take this value and we're going to substitute it for y in our second equation. Okay? So our second equation is x times y equals 10, but instead of y, we are substituting it with negative x plus 6. Okay? Alright, so the first thing, of course, we will need to do is go ahead and distribute that x value inside our parentheses, which will end up giving us negative x squared plus 6x equals 10. And then let's go ahead and move that 10 also to the left hand side. And of course you'll see we end up getting actually a quadratic function over here. So negative x squared plus 6x minus 10 equals 0. If you guys want to get rid of the negative, you can take the entire equation and multiply it by -1. So of course that means each term gets multiplied by -1, and you will end up getting positive x squared minus 6x positive 10 equals 0. Now you can try factoring this quadratic equation over here, but it will not factor, because just think about it. What two numbers would multiply to give you positive 10 and add up to give you -6? Because 10 only breaks down into 10 times 1 and 5 times 2, and none of those combinations will add up to a 6, right? So that means you cannot factor this. So factoring does not work. So you can use quadratic formula, or you can use completing the square, whichever one you want to go with. If you want to do the quadratic formula, then that would be it. So our a value, of course, would be positive 1, -6 would be b, positive 10 would be c. So let's plug that in. I have negative b, so that would be negative and then -6 inside the parentheses, plus or minus inside our radical, -6 squared minus 4 times a, which is 1, c is 10, whole thing divided by 2 times 1, and that will end up giving us positive 6 plus or minus -36 squared, sorry, -6 squared would be positive 36, minus 4 times 1 times 10 will end up becoming 40, and divided by 2. Clean up inside that square root. 36 minus 40 will give you -4, and you will see right there where you get negative inside your radical, you know we are looking at imaginary numbers here. Okay, so let's go ahead and simplify that square root. So remember, square root of -4, you can take that negative outside as your I, and then square root of 4 will of course become 2. So this will actually simplify into 2i. So let's see, we will have 6 plus or minus 2i, and then everything divided by 2. And just to remind you, I is equal to square root of -1. Okay, alrighty, so let's clean this up. We'll go ahead and separate this. Let's do this as 6 divided by 2 plus or minus 2i divided by 2. So here you will see 2 goes into 6 3 times, 2 goes into 2 itself 1 time. So this will actually clean up into 3 plus or minus I. And that actually tells us that one of these is going to be our first complex number, and then the second one is going to be our second complex number. So both of these, now if you wanted to, use them to find your your y value, you can do that. So let's say we want to find y. Of course, we have x as 3 plus I and x as 3 minus I, right? So let's start by x being 3 plus I, and what do we get? So I'm just using my first equation to simplify for this. So if x is 3 plus I plus y equals 6, let's go ahead and subtract this whole thing. these guys will cancel out. You end up getting y equals 6, and I'm going to actually go ahead and distribute that negative side inside my parentheses. So 6 minus 3 minus I will end up giving you 3 minus I, which actually happens to be my second value that I got from here. So when your x is 3 plus I, your y is going to be 3 minus I. Now let's do it the other way. If x is 3 minus I, so that's this second answer that I found from here, right? So let's see what y value comes out to be. So same thing, 3 minus I plus y equals 6. We'll go ahead and subtract 3 minus I from both sides. Cancel from here. Remember to distribute that minus sign. You're left with y equals 6 minus 3 plus I. And of course 6 minus 3 is 3 plus I. So you will see, again, when x is 3 minus I, y will be 3 plus I. So they basically end up being the two complex numbers they were asking us to find. Now to do one final check, since we know it works with the addition, if you wanted to do a check with the product to make sure they multiply to give us 10, you are taking 3 plus I, multiplying it with 3 minus I. So this will be, you can use a squared minus b squared for difference of squares. So that will end up giving us 3 squared minus I squared. 3 squared is 9. I squared is negative 1. The two negatives here become positive. 9 plus 1 will be 10. And you can see you end up getting a true statement. And of course we know when we add these guys together, you will get 6. So again, just to show you quickly, 3 plus I added with 3 minus I, you get 3 plus I plus 3 minus I. So the plus I minus I cancel each other out, and 3 plus 3 will give you 6 equals 6. So again, you will have a true statement. So either way, they work out no matter what. So our two complex numbers that they were asking us to find, so the two complex numbers are going to be 3 plus I and 3 minus I. There you go. Okay, so this is what you will need to do for finding those two complex numbers where they're telling you what the sum and the product of those two numbers is going to be, okay? Alrighty guys, so this is our last example over here, and they are talking about a screen on a 42-inch LCD TV has an aspect ratio of 16:10. They're asking us to find the length and the width of the screen to the nearest tenth of an inch. So of course when they're talking about the tenth of an inch, they're talking about 1 decimal place. Okay? Alright, so let's go ahead and take a look at this example over here. Alright, so they're asking us to find the length and the width. So let's say we're calling the length as the x variable and width as the y variable. Now they're telling us it's a 42-inch LCD TV, right? So remember that 42 inch is always measured diagonally. So the first equation that we're actually going to come up with is going to be using this idea of Pythagorean Theorem. So if you think of this as being our 90-degree angle, then your x and y sides form the legs of the right triangle, and that 42 inch will end up forming the hypotenuse of our right triangle. So we will use the Pythagorean Theorem So remember that's going to be the square of each of the legs added together, which equals the square of the hypotenuse. So a square plus b square equals c square, which in our case that would become x square plus y square equals 42 squared. So we'll call this as our equation 1. Now, of course, we need equation 2 to help us out here. So that's coming from that information they gave us about the aspect ratio. So remember they told us the aspect ratio of this 42-inch LCD TV was 16:10. So using that aspect ratio, we can come up with our second equation. So x, remember, is the length, y is the width. So that means the larger number has to go with the length and the smaller number has to go with the width. Now if you want, 16/10 can be reduced down, so both of them can be reduced by a 2. So 16 divided by 2 gives us 8. 10 divided by 2 gives us a 5. So we can go ahead and rewrite this as 8/5. Okay, and then let's call this our equation 2. Now again, to solve these two equations, you can see our system will come out to be x squared plus y squared equals, let's see, 42 squared is 1764. So this is our equation 1. And then we have x over y equals 8/5. And that's our equation 2. But you know what we're going to have to do, because again the addition method is not going to work in this case. We will need to use substitution. So I'm actually going to go ahead and rewrite my second equation, where I'm going to basically multiply both sides by y. Get rid of that y on the right hand side, so that you are basically left with x equals 8/5 times y. Okay, so let's call this, I don't know, maybe equation 3. And what we're going to do is we are going to substitute equation 3 into equation 1. Again, basically remember equation 3 is rewriting equation 2, so you don't want to substitute it back in equation 2, you want to substitute it in equation 1. So my equation 1 is going to be, where since this is x equals, this value is going to replace the x in the first equation, so that's going to be x squared plus y squared equals 1764. And instead of x squared, we will have 8/5 y. Okay? So when you square this, that of course means we are looking at 8 squared, which will be 64. 5 squared, which will be 25. And then y squared will of course be y squared. And then we have y squared equals 1764. Over here. So if you think about this, this guy has a coefficient of 1 over here, right? So we'll need to combine the like terms of y squared and y squared. That means you are adding 64/25 with 1. And again, it will help to write it as 1/1, which means we need to find a common denominator. In this case will be 25. So we'll end up getting 64/25 will stay the same. This will become 25/25, and now that we have a common denominator, we can add 64 with 25, which will end up giving us 89. So this here, once you combine your like terms, will end up becoming 89/25 y squared equals 1764. Now again, of course, our goal is to get y by itself, so let's start by multiplying both sides by inverting this fraction and multiplying both sides by 25/89. So these guys will cancel out. We've got y squared left behind, and then your right hand side, you're basically taking 1764 multiplying with 25 and dividing by 89, and you are actually going to end up getting 495.505618. So not a clean answer. It's going to be this decimal value. Now if you wanted to put this in a fraction form, let me see. Yeah, you really cannot, because in a fraction form this comes out to be where you're just basically multiplying 1764 with 25, and this comes out to be 44,100 over 89. So if you want to leave it as a fraction, you can, or if you want to leave it as this decimal, you can. Doesn't matter. Now our goal is to get y by itself, which means we will need to take a square root on both sides. So we take a square root, and remember with square root we get one positive, one negative answer, and that's going to give us positive or negative. And let me see what the square root of this comes out to be. This is going to be 22.25995548, but remember they asked us to round our answers to the 10th, one decimal place, so this will end up becoming 22.3 as our rounded answer. But remember, we are finding, and this is an application problem, because we are finding the length and the width of this television set, right? Or sorry, of the screen of our TV. So in this case, of course, you know your answer cannot be a negative number, which means we can go ahead and discard our negative answer, which means y is just going to be the positive 22.3, and this is going to be in inches because it's a 42-inch TV, right? Okay, so now that we have our y value, that of course means we need to go back and find the x, or the length of our TV. And you can use equation 1 or equation 2, but I think I'm actually going to use equation 2 over here. X over y equals 8 over 5. Okay, and of course your y value is 22.3 equals 8 over 5. And again, you can use cross product to find that value of x. So this will be 5 times x is 5x, and 22.3 times 8 is going to be 178.4, and then go ahead, divide both sides by 5, get your x by itself, and let's see, what does that come out to be when we divide by 5. This will come out to be 35.68. Again, we just need a rounded answer to one decimal place. So this will of course end up becoming 35.7, and again this will be in inches. Okay, so the length of the screen is going to be 35.7 inches. The width of the screen and that's going to be of course your 22.3 inches. And there you go. That would be your answer for this problem. Okay, so hopefully you can kind of see how you can either use the addition or the substitution method, and of course it would really depend on the type of example you have and which method seems to make more sense. Okay, so this was your handout for section 5.3. So again guys, look through the video, look through your handout, and let me know if you have any questions. We'll definitely go ahead and look at more examples when we are in class. So have a great day guys, be careful, be safe, and see you in class next time. Take care, bye bye.